Okay, Assalamualaikum. We are from Group 3. We're going to present about the electric tea kettle. So my name is Izatira binti Muhammad Taufik. The other member is Siti Nur Ain Nabila, Nur Adila, and Nur Nabiha. So first, I'm going to present about the introduction. What is electric kettle? So an electric kettle is an electrical appliance that has a self-contained heating unit to heat the water and automatically switch off when the water reaches boiling point or at the preset temperature below 100 Celsius. Next is who discovered the electric kettle? The credit for the creation of the first electric kettle goes to Russell Hobbs, a company established in the UK in 1915 by William Russell and Peter Hobbs. Before this, electric kettles could evaporate completely if unattended or cause an electric shocks. Okay, and then what is kettle material made of? So, the glass, iron, silver, aluminium, or a mixture of plastic and metal are the main material used to make the electric tea kettle. All metal kettles are normally housed in grade steel. In certain models, heat-resistant plastics such as low-density polyethylene, polypropylene, and polystyrene form the upper housing of the kettle, with the metal enclosures on the bases containing the heating component. And then, what is the best material for a kettle? So, as we can see, the best material is steel because uh, it is considered the best material for durability. And the electric kettles that use the glass are often popular with people who favor aesthetic and like being able to wash the water bowl.
Okay, next is product function. Electric kettle, also known as a tea kettle or teapot, is a type of pot specifically for boiling water with a lid, kettle, and handle, or a small kitchen application of a similar shape that function independently. The kettle can be heated by their own internal electric heating element in application version. Unlike traditional kitchen kettles, electric tea kettles are very efficient and come with several innovative features. This is one of the many reasons why electric kettles are so popular.
Okay, next we move to the next part, which is the manufacturing process involved. Okay. So we present about the base, supply plug, housing for electronic component in the base, top lid, and handle. So first I will explain about the metal base, which is contain the which connect the supply plug and the plug and the housing for electronic component in the base. Okay, first I will explain about the base. Okay, the base of the kettle has the indent in the middle for a convenient setting onto a deck which provide electricity to heating element of the kettle. The outside plan of the base completely flat, ensuring the upright position of the kettle, preventing any spillage, and assuming the surface of contact is horizontal. So first, the process is we prepare the plastic pellet. It is plastic pellet, and then we complete the electrical part, which is in this. The electrical part molded in this, and then we form the shape of the kettle base, and the metal stamping process happen to shape the base, and then they mount the kettle base with the power component. This is power component, and inside the connector between the heating unit and the cards. And then they seal together the metal base with its electrical components and the plastic housing. Okay, next I will explain about the plastic housing. It is this one. Okay, the plastic housing is using polypropylene materials to form it, and then the process is the first one they are forced into an injection molding machine, and the liquid plastic is forced under a high pressure into the steel box, and then they will eject the plastic kettle housing and cool it down first. And then the workers will manually fit the metal feed covers, this one, onto the plastic sprouts to prevent the spilled water. Okay, that's all from me.
Okay, next the thermostat. Our kettle heating function is operated by the thermostat switch. A thermostat is a system that detects and responds to temperature change. It may be mechanical, electrical, or electronic. It detects the system temperature and perform behavior following its setting. The thermostat is an essential part of the kettle temperature control system. Okay, next, the thermostat we have is made up of two parts of different metal brought together to form a high quality bimetallic strip. Each metal in the strip expands and contracts at different rate. A bimetallic strip made of brass and iron, for example, expand less than brass as it picks up the position to the circuit, causing the heater to begin. Bimetallic strip bending is caused by the gradual heating of the strip, which allow one the metal to expand more than the other. The circuit is broken open as a result of the bending. Then the last is the bridge is up in the location, and the flow of electricity to the heating element is disrupted. Okay, the last one is a steam outer shut off feature and a tri-burn protection feature and framework. The steam thermostat turn on and off the heater. The steam had subsided to get to the turn go through the pipe in the kettle handle. As a result, the kettle will not turn off until the water has been heated. The steam thermostat the steam thermostat been down and close the circuit when the button is pushed. The size and thickness of such a bimetallic disc have a significant impact on how it bends and flips. The last is the thermostat also with the letter K on it was triggered and it won the break the secret when the kettle chop in empty it right next to the heating unit. That's all for me.
Okay, next is screw and spring. For screw are usually made from low to medium carbon steel wire, but other hard and inexpensive metal may be replaceable, such as stainless steel, copper, nickel alloy, or aluminum alloy. A larger number of screws are mass-produced using the cooling heading and thread rolling method. Steel wire type material is used to make electric kettle spring. There are several manufacturing processes for making spring, which is coiling, hardening, and finishing process. Okay, next slide. For screw, through a cooling heading process, the wire is inserted from the mechanical coil through a pre-stressed straightening machine. The straightened wire flows directly to a machine that automatically cuts the wire at a specific length, and the die cut the blank screw head to a program shape. Head machine use open or closed die that require one shoot or two shoot to make the screw head. The closed or solid die produce more precise screw closure. On average, cool head machine produce 100 to 450 screw blank per minute. Next, through the process of heading rolling in turn, once cool-headed, the screw blank is automatically inserted into the thread cutting die from the vibrating hopper. The hopper guides the screw blank down to shoot toward the die while making sure it is in the correct bed position. Next, the blank is then cut using one of three techniques. In repeating die, two flat die are used to cut the screw thread. One die does not move while the other moves repeatedly, and a screw blank is rolled between the two when a cylindrical die without a center is used. A screw blank is rolled between two to three round die to make finished thread. The last method of thread rolling is the planetary rotation die process. It holds the blank screw stationary while the cutting machine warps the blank. Next, winding process. There is a cold winding process. The 0.75 inch diameter wire was wound at room temperature using one of two basic techniques. One consists of winding a wire around a rod called an able or mandrel. A guide mechanism such as a lead screw on a lathe should be used to align the wire to the desired tone when winding the mandrel. The wire is pushed forward on the spot block toward the recess head that deflects the wire, forcing it to bend. The head block and support can be moved against each other in 5 directions to control the diameter and tone of the spring being formed. For elongation or torsion spring, the end are bent into the desired lock, hook, or straight section after the coil operation is complete. In addition, there is a hot winding process. Thicker wire, stock, or bar can be rolled into spring if the metal is heated to make it flexible. Steel is wrapped around the mandrel while red hot, then removed from the machine the coil and put in oil to cool it quickly and harden it. At this stage, the steel is too brittle to function as a spring and must then be softened. Finally, the finishing process. In this process, there is a grinding process. If the design requires a flat end in the spring, the ends are ground at this stage of the manufacturing process. A frame is mounted on the jig to ensure proper orientation during grinding and is held on a rotating rough while until the desired level of flatness is obtained. When highly automated equipment is used, the spring is gripped with an arm while both ends are grounded simultaneously with a coarse wheel and then with a finer wheel. A propelled liquid can be used to cool spring, lubricate grinding wheels, and carry particles during grinding. Next, the pinning process. This process strengthens the steel to withstand fatigue and cracking of the metal during repeat blows. The entire surface of the spring is exposed to a string of small steel balls that finally hammer and compress the steel located just below the surface. In addition, there is a setting process to fit the desired length and tone of the spring. It is fully compressed so that all the coils are in contact with each other. Some manufacturers repeat the process several times. Other than that, there is also a coating process. To prevent corrosion, the entire surface of the spring is protected by painting it, dipping it onto molten rubber, or plating it with another metal. One process called mechanical plating involves dropping a spring inside a container with a metal powder, water, acceleration, a chemical, and small glass bead that punch the metal powder into the surface of spring. A negative electric charge is applied to the spring. Also embedded in the liquid is a supply of platinum metal, and it is given a positive electrical charge. Because the platinum metal dissolves in a liquid, it releases positively charged molecules that are attracted to a negative charged spring, where it is chemically bound. Electric plating makes carbon steel spring brittle, so shortly after plating, they must be baked at 160 until 190 Celsius for 4 hours to overcome absorption. The final process involves it. This finishing process is the packaging process. The desired quantity of spring may be packed in larger quantities in board or plastic bag. However, other forms of packaging have been developed to reduce spring damage or clutter. Okay, next slide is body. The body of electric kettle is made of stainless steel. The stainless steel body is formed using sheet metal with constant thickness. It is placed in hydraulically operated press machine, which is then released to form a hollow casing. This process is also known as deep drawing. The second sheet is placed on the punch press using a different die. This sheet is formed to withstand the heating element and form the base of the kettle body. The two are then welded together to form a stainless steel casing for the kettle. In the kettle inspected, only one strand was used, while the second was replaced by polypropylene. The nozzle of the kettle is made by molding, which can form a die or forging. The die formation is similar to deep drawing in that the method is pressed on the die with the desired shape. Forging provides concentrated pressure to create the required shape. Containers are usually used. The part is then welded to the kettle. The body now completes ensuring an aesthetic appeal.
Next, we will move to the next step, which is a wire. Okay, wire is an electronic conductor that made from copper or aluminum, which can allow electricity for its solution that can make the current flow can go anywhere without leaking at anywhere. Okay, so the first step is wire drawing. Okay, wire diameters can be reduced to be present value. This wire must made from copper or aluminum, but usually we use copper as the main material. The wire need to be pulled out through a synthetic diamond because it is the method that we can use, so we can draw the hole on the edge. This processing with lubricating and also cooling system can increase life of the dies and deter wire from overheat. Okay, the second step is annealing. Heat can treat the wire to improve the wire's physical properties, same as conductivity and ductility. Heating the wire to recrystallization the temperature for a decade. When withdrawing, it can give a lot of pressure to metal rod to forming the wire. Wire can get easily broken because it is fragile if we bend it, so the finishing wire need to be flexible and we can soften the wire. Next slide. Okay, in this step is twisting and stranding. In this process, the wire need to combine so it can create conductors in varying cross sections. When wire twisting and stranding, it can have a better flexibility and electrical performance. And then next is extrusion. Hot extrusion is a process where conductor need to be covered with insulating materials. These materials at choice depends on requirement needed by wire and capacity and also thermal resistance. Copper will forcing the metal through extrusion to create particular shape. But if we want to create cables, ingot which is copper but basically a pure copper to stretch into long strands. Copper will heat until it becomes flexible, then being pushed to the machine. At a certain temperature, this machine will start to pull and form the copper and decide which thickness cable can be. And then, next slide. Okay, for the last step, which is cabling. It is to differentiate the wire with different color, number, or other to make them not same with each other. After that, we will add more protection to improve the characteristic. Just for in case it has high electrical stress or highly demanding of operation condition. Wire signal also need to be insulated with a screen to protect from any damage. We can use steel or aluminum. This is because it can protect the moisturized add elements and avoid wire from mechanical impact. Next slide. Okay. This is insulation for wire. Okay. Insulation of wire is a non-conductive material such as PVC. This PVC surround and protect the wire or cable. Okay, some production of insulations are for resistant the electric current in electrical application, and the other is to use for the electric applications for radio frequency cable. Next slide. Okay. This process need to be added into the process of extrusion at really high temperature. When the wire becomes soft and flexible, it can come through extruder where they are coating. It is a plastic insulating or any material can be used. When high capacity and insulating is thickness, higher maximum of surface that voltage of wire can reach. If higher thermal resistance, it can make conductor transmit more electrical power. And then next is it can be coated when wire pass through another cooling system and rest cooled on rails. After that, we need to try the voltage to make sure that insulation are free from any faults and no current leak. Whole length of cable need to undergo a voltage test also to make sure the insulation of layer do not have any mistake. Okay, so this is our last slide from our group, which is conclusion. When we need to produce something, we need to do a proper selection for the material and ensure if the manufacturing process can be used really well to prevent something bad happen. Electric kettle has so much material that need to be selected to be suitable, which is include stainless steel. So we need to make sure that everything goes well with what product that we need to release to other people.